Okay, so this is the fifth assignment called concrete data. Let's start with the introduction given here. So we have a dataset named concrete data. It has been chosen from the UCI repository, which is available online. It has 1030 observations with 9 attributes. The data is about the various variable components that are responsible for defining the strength of the concrete. We will have to do basic statistical operations on the dataset, and the analysis has been divided into 4 sections, with each section starting with a question. So let's start with the first section. Here we will import the data and perform some basic data exploration. So let's import the data and store it in a variable called concrete. You can get the CSV file in the description box. After reading the data, we will first check the structure of the data using str function. We can run this and we will get our output. Here we can see that there are 9 variables and all of them are numeric. Then we can also check summary using the summary function. Here we are storing the summary in a variable called sum. We can check it if required, but for now I am moving forward. In the next section, we will check for missing values and note the number of missing values. So we can use the function sum, bracket open, is.na, which will basically check whether value is missing or not, and then again bracket open, and then our data, that is concrete, and then close the bracket. So we can run this and we will get all the missing values. After this, we will check for outliers using box plots. So to plot a box plot, we will first use par function to accommodate multiple graphs on one screen. Then we will use for loop. We will run the loop from 1 to 9 for all the variables. The command for plotting the box plot is boxplot. Then we will give the first argument, which is variable for which plot is required. So we need for all the variables, hence we will subset our concrete data using I, which will take value from 1 to 9 as the loop progresses. We can give some more arguments such as color of the plot is red, main title is box plot, xlab, that is x-axis, would be the name of column of our data. So to do this, we will have to subset the data using I again, and so on. Then we can run this and we will get our box plots as shown here. Now let's inspect the box plots. So by looking at the box plot, we can conclude that there are outliers in the undermentioned variables. But as you can see, the names are not properly displayed under the box plot. However, when you will plot it in R, you can see all the names properly. There is some glitch, I believe. Now I have mentioned the comments here. Let's refer to the comments. We have one outlier in the slag component. We have 3 outliers in the water component, 2 in the super plasticizer, 1 in the fine aggregate, and 3 in the compressive strength. To identify the outliers, we can just look at the box plot. The points that are lying outside the boundaries of the box plot are considered outliers. So it is this easy to identify the outliers using box plot. Now moving to section 4. Here we will be calculating correlation of all the variables with a variable called strength MPA. So first we will subset the strength variable and store it in a variable called MPA underscore concrete. In our dataset, the 9th variable is the variable for MPA strength. You might have noticed this above when we check the structure of our data. We can scroll back and see it again in the output of the str function. So let's scroll back. And here it is as shown here. Now after this, we will segregate rest of the variables with which we will check the correlation. So we will check the correlation using the cor command and then store it in the variable cor. Now as you can see in the formula, the first argument is the MP underscore concrete, and then the second argument is the rest of the variables which are stored in the rest underscore concrete variable. So that is how we check the correlation. Then for a better understanding, we can also visualize the correlation using bar plots. So first we will define the legend for our plots, which are basically the names of the variables. To do this, we will create a variable called legend as shown here. Write the names of our variables in the vector like cement, slag, fly ash, etc. After creating the legend, we can plot the bar plot. Here we only need one graph on the screen. So we are using par function with mfrow is equal to c11. This will give one graph on the screen. Then we will use bar plot function. Give the first argument, which is correlation values. Then we will mention beside is equal to true. So bar plots can even create a stacked plot. Let's say if we had our data in the form of matrix and each variable had say yes or no values. So in that case, we would have gone for a stacked bar plot. But here we have only vectors and we don't want stacked bar plot. So we will use beside is equal to true. Next would be the color argument. For different bars, we will mention different colors. As there are 8 variables excluding age that is not considered in correlation, so we will have 7 bars because we are checking correlation of one variable with the rest of the 7 variables. So we will define a color vector with 7 colors. Then we will mention the name of y and x-axis as shown here. After this, we will mention the legends using names argument. And finally, we will mention the limits of our graph. That is, y-axis will vary from minus 0.6 to plus 0.6. We can mention this value by looking at the range of correlation values, but I mentioned it randomly here because anyways correlation will lie between minus 1 to plus 1. These will be all our arguments. Now we can run this command and we will get our plot. Now as you can see the bar plot here, we can conclude the maximum positive correlation of strength of concrete is with cement and maximum negative correlation of strength is with water. So that is how we can visualize the correlation using bar plots. Now that is all from this assignment. Today we have learned few new concepts. First we identified the outliers. Then we plotted the box plots. Also checked the correlation between variables. And then plotted the correlation on a colorful bar plot. So we got to know some new functions today. Well, I hope you liked the video. Now I'll see you in the next video. Until then, see you.